Imagine cramming the surface area of a football field into a shot glass. If such an expansive surface area in such a small package could trap deadly toxins, you'd have one powerful defense against hazardous waste spills, perhaps even against chemical attacks. Well, that's the concept behind FastAct, a family of products recently created by Kansas-based Nanoscale Materials Incorporated to capture and neutralize corrosive acids, toxic industrial chemicals, even chemical warfare agents. FastAct is composed of harmless, naturally occurring minerals made from magnesium, titanium, and oxygen. For several decades, researchers have known that these minerals can absorb and break down toxins, but there was no way to make the compound efficiently and in large quantities.
With the support of the National Science Foundation, Nanoscale developed a method to produce vast quantities of FastAct by using nanoengineering, or engineering at the scale of dozens of atoms. The new material is not only cheaper than the laboratory version, it's more uniform, more predictable, and even more effective.
The critical properties, surface area and reactivity, enable emergency teams to quickly and effectively counter virtually any liquid spill or vapor release, even if the responders don't know which toxic chemical they face. Many hazardous chemical treatments only absorb toxic substances, which can later detach and be re-released. In contrast, for many toxic chemicals, FastAct encapsulates, neutralizes, and destroys the deadly substances quickly. In tests by the U.S. Army and Battelle Memorial Institute, FastAct removed chemical warfare agents from surfaces in less than 90 seconds, then went on to destroy them, forming much safer byproducts. When a scoop of FastAct mixes with liquid containing parathion, a common toxic insecticide, the normally white FastAct powder turns yellow, indicating not only absorption, but breakdown of the parathion into other chemicals. The toxin is destroyed. Gas chromatography, a technique used to determine the chemical components of a mixture, reveals how much parathion the treatment removed. In this test, 3 samples are run. The results? Parathion in a solvent without any treatment. After treatment with the absorbent emergency responders most commonly use. After treatment with FastAct. The common absorbent was not effective at removing parathion from the solution, while FastAct removed and destroyed all of it. In his laboratory at Kansas State University, Nanoscale founder Dr. Kenneth Klabundy was first to develop the techniques that ultimately led to FastAct. Support from NSF's Small Business Innovation Research Program helped Nanoscale create the manufacturing processes that allow commercial-scale production.
The technology is extremely innovative and may prove to be critical during emergencies.
Nanoscale is currently working with a number of emergency response officials nationwide to provide a safe solution in the event of a toxic chemical release. The company envisions its FastAct units becoming as common as fire extinguishers in airports, subways, and other public facilities, where an immediate response to a release may mean the difference between hazard and catastrophe.